Hello everyone, today on the workbench we have a power inverter that does not function with battery or any 12-volt DC power source. The story behind it, as told by the owner, this was being connected to a battery that, unknown to him, the inverter power switch was in the on position. The positive terminal made a spark and then did nothing else. After that incident, it no longer worked or any of the LEDs turned on, and he tried messing around with it, but no luck. So let's open it up to see what could be the fault. I already removed some of the screws from the lid to make things a little faster, and then take off the cover of the inverter to expose electronics. To what I've researched, this kind of unit is a high frequency inverter producing a square wave. And I also found that if the inverter has a toroidal transformer, it would be a low frequency inverter that is better for inductive loads. This unit has two ventilation fans that activate when the temperature inside of the unit is hot enough or under hard load. So the way this thing makes AC voltage is by using these transformers. They are in a full H-bridge configuration, to what I have read about this, and it's powered by MOSFETs that act as fast switches that in turn are controlled by an IC to rapidly switch between each other to create the oscillation, in this case square. So I would need to read that in more detail, but I found a great video explaining how this thing works, and I'm going to leave the link in the video description. Following what I was told about when this failed, I will start by testing the fuses. I think it is what took most of the energy surge to protect the inverter components. So to test them, I have set up my multimeter in continuity mode to check for the DC positive side input. With this short test, we verify fuse condition. Let's test them. We put the leads in series with the part we want to measure. We were right about the fuses. All 6 of them blew out. So we will need to remove the main board from the enclosure to replace them. First, we need to remove the screws holding the brackets of each MOSFET and the regulators. Then we remove the screws holding the front plate and slide the main board off the enclosure. We can leave the plates attached to the wires and to the end connectors. That way we can get access to the blown fuses. Now we are going to unsolder the fuses. I have my hot iron or my soldering station set at 450 degrees Celsius, and I'm going to use a medium-sized tip. And it's simple as when the solder is liquid enough, we take the solder bulb to suck in the solder. And I like to try to remove as much as possible, so as not to use too much the soldering braid to remove as much of the solder as possible from the pads. I don't want to bore you with this process, but you get the idea. So I will replace these fuses and show you the results afterward. All fuses were replaced, and as you can see, these are not the best fuses, but they do work. And that is what I had in hand in such a short notice. Now let's place the PCB brackets in enclosure, install all the MOSFETs and regular brackets, not forgetting the thermal pads. Before installing the lid for this inverter, we're going to test if in fact it's working and that no other components were damaged. To test this, I'm going to use my 10 amp DC power supply, and I'm going to attach a bulb in the LED bulb in the AC power output. So you can see these are not the proper size alligator clips. Is what I had at hand, and they work okay. Right, let's check for 12 volts in the input side of each fuse to test for possible open circuits or cold solder joints. Then power up the unit with no load. The reading in the output side should be between 110 to 120 volts approximately, with an RMS meter. As this is a square wave inverter, using a non-RMS meter will give you about 87 volts AC or somewhere in between. Now let's connect the 120 volt LED bulb to verify power output. Of course, a 500 watt halogen would have been better, but I have none at hand. And no load tester either. So you can see the LED turned on, no fires or explosions or anything. So this was an easy fix, and thankfully no other components were damaged. Now let's close it down, put it all back together, return it back to its owner, and in my opinion, this I will say, I suggest that if the installation is not permanent, check the power switch position anytime the equipment will be installed to a battery, or if a heavy load is connected to its output, to always install the inverter with all loads off to prevent surge conditions. If the installation is not permanent, check the power switch position anytime the equipment will be installed to a battery, or if a heavy load is connected to its output, to always install the inverter with all loads off to prevent surge conditions, and always connect positive side first and negative last. Also, as a chip protection, have a mains fuse on the positive side. It's better to replace the external fuse than to take the whole thing apart in an emergency, especially in the dark. And as always, hope this has been helpful, interesting, or at least entertaining. If you enjoyed this video, leave a comment. If you want to see more like it, stay tuned. Until next time.